Today's lesson is called Scientific Notation Day 1. It's actually an application of exponents. So scientific notation is a specific way that we write either really large or really small numbers. So scientific notation is written in this format right here, where this number right here has to be larger than 1, or well actually larger or equal to 1, and less than 10. And then we also have to have that multiplied by 10 to some power and some integer power. So it can either be a positive or negative number. So the first number has to be between 1 and 10. So if I'm looking at question number 1, it says determine if the following are written in scientific notation. Right here, this first number is larger than 10. So the rest of it times 10 to the 12th is good, but this is a no because this 56.29 is larger than 10. 0.84, that is not written in scientific notation because that number has to be 1 or larger than 1. The next one, we have 6.11 times 10 to the 5th. 6.11 meets the first criteria. It's greater than or equal to 1, but it's also less than 10. We're multiplying by 10 to some power, so that's a yes. Over here, 3.42 times 10, this really means 10 to the first, so yes, that's also in scientific notation. So what we can do then is we can move from standard notation to scientific notation. So this is actually standard notation, it's what you're used to. What we need to do is figure out where do we need to place the decimal in this number so that we can create a number that is greater than or equal to 1 but smaller than 10. So if I put it here, I'm getting the number 524, which is not going to work, 52.4 or 5.24, which is where I need it to be. So I'm going to start by writing off 5.24. I don't have to include the 0 because it's kind of just extra. And I'm going to put times 10. Since this is a larger number, I'm going to have a positive exponent. The exponent is going to tell me how many times I'm going to actually be moving the decimal point to create the original number. So from here, I'd be moving it 1, 2, 3 times to the right to create the original number. So my exponent is going to be 3. In here, I'm going to put the new decimal point between the 6 and the 7, so 6.72. Notice how this is a much smaller number. It's less than 1. So I'm going to have to be moving the decimal point to the left. That tells me it's going to be a negative exponent. It's going to be 1, 2, 3, 4. So 10 to the negative 4th then. So really large numbers are going to have positive exponents. Really small numbers are going to have negative exponents. So again, down here, a positive exponent, move the decimal point to the right that many places. A negative tells you to move it to the left that many places. So in this one, we have 4.5 times 10 to the 7th. So we have 4.5, we need to move it 7 places. 1, 2, 3, 4, 5, 6, 7. It's actually where the decimal point belongs, and we plug in zeros in all these spots. 1, 2, 3, comma, 1, 2, 3, comma. If we take a look at number 8, this one has a negative exponent, which tells me it's going to be a small number. So I'm going to put 5, 2, 6, 1. Decimal points here, I need to move it 8 spots. 1, 2, 3, 4, 5, 6, 7, 8. Goes here. I'm going to put a 0 out front just so that it's looking nice. And there you go. Notice that's a really, really tiny number. So when we order these from least to greatest, we need to make sure that they're all in standard notation first. Once we do that, we can look at the exponents. Obviously, negative exponents, the larger the negative number, the smaller the actual number is. So what I'm going to do is actually re-put these into scientific notation, because if you look, none of them are actually in scientific notation now. So the first one is going to be 6.02. Since I actually lost, we're going to call this losing because we're moving it to the left, I lost a point. This is actually going to gain 1. So it's going to become 10 to the negative, times 10 to the negative 4th. Forgot my times 10 part. Here, 6.3. Again, we're losing a decimal point, 1 spot. So this is actually going to gain 1. So it's going to become times 10 to the 5th. This one right here, 6.7. So I'm actually gaining 2, which means this is going to lose 2. So times 10 to the first. And this last one, I'm losing 1. So this one's going to gain 1. So it's going to add 1, which makes me to the negative first power. So now looking at these, this one is actually the least because it has the lowest exponent. So my least is going to be 60.2 times 10 to the negative fifth, going back to the original format of it. My next is going to be this negative 1. So that was originally 61 times 10 to the negative 2. And 10 to the first or fifth, this would be next, which was 0.067 times 10 to the third. And the last one would be this one, the 63 times 10 to the fourth would be the greatest then. So this is least to greatest. Last example here, the following masses of parts of an atom are measured in grams. Order the parts of an atom from least to greatest. Notice these are all in scientific notation already. So we can really just look at the exponents. This one is going to be my least because the exponent is the largest negative number. Between these two, since the exponents are the same, I actually have to look at the number. 1.6749 or 26. This is going to be the smaller one because this number is actually smaller than this one. So this will be my middle, and the neutron is going to be my greatest.